When answering questions that deal with box plots, it's important to know the different parts of a box plot. A box plot has the general shape of a box with two lines sticking out of it. The very first line is a minimum. The first part of your box is quartile 1. The line that goes through the center of your box is your median. The last part of your box is quartile 3. And the last line is your maximum. Each part, so from line to line, contains 25% of your data. So each of these parts right in here is 25%. Even if one part looks bigger than another, it's still only 25%. Use the parts of a box plot to answer questions 1 and 2 on your statistics review. When you are asked about things such as mean, median, quartiles, interquartile range, or standard deviation, you will want to use L1 in your calculator. Anytime you see those words, you should have a list of numbers you want to put into L1 in your calculator. So if you look at question 3, Christopher looked at his quiz scores shown below for the first and second semester of his algebra class. Semester 1, he got a 78, 91, 88, 83, and 94. Semester 2, he got a 91, 96, 80, 77, 88, 85, and 92. Which statement about Christopher's performance is correct? The interquartile range for semester 1 is greater than the interquartile range for semester 2. The median score for semester 1 is greater than the median score for semester 2. The mean score for semester 2 is greater than the mean score for semester 1. And the third quartile for semester 2 is greater than the third quartile for semester 1. All of those words, quartile, mean, median, or standard deviation if it were in there, would be found using 1 var stats on our calculator. So what you would have to do is take one semester at a time. And you're going to put those numbers into your calculator. So in my calculator in L1, I'm going to do 78, 91, 88, 83, and 94. So I have to do stat and enter to edit. And if you have anything in there, clear it out by hitting clear. Remember, do not hit delete, hit clear. And then you put in your numbers. And then to calculate your statistics, you do stat over, and you want one variable statistics. One variable statistics encompasses everything, including mean, median, quartiles, and standard deviation. Your little X with a bar over it at the top is your mean. SX is standard deviation. Min means minimum. Q1 is quartile 1, med means median, Q3 is quartile 3, and max is your maximum. Now, if you look at our question, we're talking about interquartile range. If you remember, your interquartile range, or IQR, is Q3 minus Q1. So we'll look at our Q3 and Q1. And that would be 92.5 minus 80.5. Which, if you did that in your calculator, would give you 12. Median, remember, is MED, which is 88. The mean, remember, that's your X with a bar over it, which in this case is 86.8. And third quartile, our Q3, we already found, but we can go back and look at it again if we want to, 92.5. Now, you'll need to do the same thing for semester 2. You will have to put those numbers in your calculator, find each of those values for semester 2, and then determine which choice is correct. Now you can try questions 3 and 4. The table below shows the attendance at a museum in select years from 2007 to 2013. State the linear regression equation represented by the data table when x equals 0 is used to represent the year 2007 and y is used to represent the attendance. Round all values to the nearest hundredth. Now, a linear regression equation. Linear and equation. You should be thinking y equals ax plus b. Or some of you like to think mx plus b. In order to do this, we need the linreg command in our calculators. Now, something I want to draw your attention to in this specific problem, it doesn't happen every time, but in this specific problem, it says x equals 0 is used to represent 2007. So when we put this in our calculator, instead of 2007, we're going to put a 0. Now we have to think, how many years after 2007 is 2008? 1. 2009 occurs 2 years after that. 2011 occurs 4 years after 2007. And 2013 occurs 6 years after 2007. These are the values we're going to put into our calculator. Now remember, when we need linear regression equations, we need both numbers in our calculator. So same thing, we're going to do stat and edit. And we're going to clear out what we have. And then I'm going to start with my x values, 0, 1, 2, 4, 6. And then I'll do my y's, 8.3, 8.5, 8.5, 8.8, and 9.3. Now to get my linear regression equation, I'm going to do stat over to calc, and I want to go down to number 4, which is linreg. And I'm going to hit enter. Now remember, I have to plug in for A and plug in for B. It asks me to round to the nearest hundredth, so that's 2 decimal places. So I'll have y equals 0.16x plus 8.27. Remember, 5 or more, raise the score. This is what I need if it asks for a linear regression equation. I need a y equals, and you have to have your x variable in there. You cannot just write y equals ax plus b, a equals b equals. I need it in this format. Now it says to state the correlation coefficient to the nearest hundredth and determine whether the data suggests a strong or weak association. Remember, correlation coefficient is your R value. If you don't see your R value there, you probably didn't turn your diagnostic on. In order to do that, you would hit second, 0, scroll down to diagnostic on, and hit enter until you see done. Then you would have to do this again, stat, calc, lin, reg. So my R value to the nearest hundredth is 0.97. Now it asks whether this is strong or weak. Remember, if your correlation coefficient is close to 1 or -1, it is strong. If it's close to 0, it's weak. And if it's kind of in the middle, like 0.5 or -0.5, it's moderate. 0.97 is very close to 1, so this is strong. Now you can try question number 6.